Hello, everyone, and welcome to today's edition of Applied AI Lunch Talk. It's going to be the second last of the semester, and we're super excited to bring back a former Applied AI Lunch Talk veteran and a new one. We are also starting to think about the spring semester. So if you have any ideas for who you'd like to hear from on Applied AI Lunch Talk in the spring, you can send me an email. And let's see what we have in store for you today. So as I mentioned, we have an Applied AI Lunch Talk veteran. It's going to be Shabab Akhter, who's joining from the ROCKWOOL Group. And with him, he's bringing Pohali Taha, who's joining from Sater. They are servicing Airbus's machines after they've been sold. So it's super important stuff that they do to keep us all in the air and not on the ground when we don't want to be there. So I'm really excited to see you on stage in a minute or so, or less probably. But what I also want to advertise, if anyone has to leave before we're at the end of their talk, is that December 5th, we have Frederik Warburg come in and talk about Teton AI. They're supplying AI-powered solutions for nurses, so health tech. And we also have Torana Bender, who has been working with AI, with Vivino. It's an app where you can rate your favorite wines. And she promised to bring some wine. So that's going to be super exciting. A lot of extra motivation to show up physically here at Skylab, perhaps. So that's December 5th, and you can use the QR code behind me if you want to sign up for it. Sign up is needed if you want to receive the link and view the talks online. So without much further ado, I'm actually ready to invite Pohali and Akhter up on stage. And we're just going to switch slides. So please give them a big hand.
Mic on?
Yes. Can you hear me? Yeah.
Can you hear me? Awesome. Okay.
And take it away.
Yeah. Okay. So, hello everybody. So my name is Pohali, and this is Shabab. And first and foremost, before we get into introduction, I would like to thank you all for joining us today. And I hope we'll be able to keep you entertained for the next 30 to 45 minutes, yeah? So why we're here? So we are here today to decode, right? Decoding a carrier in data. And we're going to talk about from a data analyst and a data scientist point of view, right? What do we do in the industry? And what are the things we need to keep in mind? How do we build a product, right? So yeah. Maybe we can start off with today's agenda. We will introduce ourselves, of course. We're going to talk about different use cases from industry point of view, and how do we kind of build products, right, for the companies. And then we're going to talk about how a data engineer, a data analyst, a data scientist come into the scene to build products for the companies, right? And then, yeah, we are going to finish it off with some remarks and Q&A. Now, for the introduction, my name is Pohali. I'm originally from Bangladesh. I have a computer science background with a focus in data analytics. I have experience with big data in the aviation industry, and I'm currently working as a data analyst and also a data engineer in the finance domain. Now, giving the floor to Shabab.
Maybe I take that as well. Yes, so thank you again to all of you for being here today. My name is Shabab. I'm also originally from Bangladesh and have a similar background in computer science. And I have about 7 years of experience working as a data scientist and roughly 5 years also in consulting. Today I work at ROCKWOOL as a team lead of the data science team. And we do all things AI. We can talk about more into that later on. Then if we dive into today and what we are going to touch upon, then the first thing that I will start off with is to look at some use cases. So as Poheli mentioned earlier, we will take you through what data engineers do, what data analysts do, and what data scientists do at a company. But before we go into those, we have to first see what is it that they are trying to deliver. So a bit more on the high level. And here we would like to start with some practical use cases. Here are some examples of some typical use cases that people in the industry work with. There can be various use cases. I've just brought 3 today as examples. One could be in finance, where you are trying to predict if a customer will not pay an invoice on time. It could also be in manufacturing, where you're trying to predict if a machine is going to break down all of a sudden. It can also be in supply chain, where you're trying to predict or do route optimization and find out in what order should I deliver my goods in order to use the least amount of money and also least amount of fuel so that it's good for the environment. So these are some type of use cases that engineers, analysts, and scientists work with in the industry. For the purpose of today's talk, we will take the conversation based on the finance use case and build on top of what does an analyst do, what does an engineer do, what does a scientist do with regards to this specific use case. So in the screen you see, and this is typically how our life at the company works. You would have someone from the business come to us, show us a table like the one over there, where you have like some of these names of people and saying, you know, I want to see, first of all, who has paid or not paid on time in the past. And then I want to see in another column whether they will pay on time or not in the future. And that's basically it. And then they say, you know, this should be super simple. I just want 3 columns from you. And with all this cool AI stuff, it should just take you 2 days to do this. So let's meet back again in 2 days, and you can tell me which of my customers have not paid in time in the last month and which of my customers will not pay on time next month. Easy. We will do it. And that's usually how these conversations begin. And we will take you through what we do to actually do that. Maybe not in the 2 days time frame, but yeah, what are the things that we actually do to get there? And to get there, the first important concept to understand is we do these use cases by delivering data and AI products. And this will be sort of a central topic of today. And to start that off, we have to first define what are data and AI products. It has something to do with the nice picture of the cake that we have on the screen, but I'm going to give it back to Poheli now, who will take you through this.
Okay, the picture of the cake is just to get your attention, just so you know. So now I have your attention, right? Okay, so the cake, right? But no, I was just kidding. The cake plays a very, I would say, important role in here, right? In understanding what exactly is a data product or an AI product, right? So, if we talk about a cake, right? You bring a cake so nice, cherry on the top, well decorated. Oh, okay. Well decorated, but to build a cake, you need to layer it up, right? We have a first tier layer, we have a second tier, and then third tier, and then at the end we ice it up, decorate it. Okay, good to go. But if you slice it open, right, you will see different cake has different layer. So when we talk about building a data product, we can build it. Maybe we can build it in 3 tiers. So tier 1 is basically a basic tier, and in this tier we basically create tier 1 data product, we call it. So what is a tier 1 data product? Whenever we are talking about any use case, for example, the finance use case, right? We want to create a product where I can see, okay, which of my customer is paying on time in the present and which will be paying on time in the future, and then who will be late, right? So to create that use case, I need to start from the very bottom. So the base tables will basically give me all the customer detail, right? When they're paying on time, what is their due date, and so on. Then we move to tier 2. So tier 2, basically we call it intermediate data product. They're basically a combination, a lot of tier 1 data product, and then we basically use them to, build dashboards and maybe for further analysis. And then we move to the fun part, right? The tier 3 data product. We call it advanced data product, where we do AI integration, for the prediction and the fun stuff of it, like who is going to be late in the future, who is going to be my, customer who will pay on time. So this basically is the cake analogy when we want to talk about data product. but let's deep dive into, how do we build these kind of tier 1, tier 2, and tier 3 data product. Today, as a data analyst, I will be focusing more on the tier 1 and tier 2 data product. And then, Shabab will talk more about the tier 3 data product. So how do you build tier 1 and tier 2 data product? When it comes to building anything, I think the very first thing from industry point of view is doing a requirement analysis. Somebody cannot just come to me that, okay, give me a table where I can see my customers and then see who are going to be late and who are going to be paying us on time. But that's not enough, right? I really need to get deeper into, okay, what do you actually want to see? How do you define who's late and who's not late, right? So we basically start off with interacting with the end user, that what do you want to see? And then we also then in the next stage, we also try to understand the people who are working with this data, like putting this data in the system. Like how do you kind of connect customers to a due date, and what is their trend in paying on time or paying late, right? So we also interact with the ground force, people who are actually putting this data in the system. And then we do the documentation, because whenever we are doing requirement analysis, it's very important to do documentation so that everything can come together. And when we're doing this brainstorming, we have all the knowledge that is needed to understand, okay, how things communicate with each other, how the dots connect, right? So we first interact with the end user, we interact with the ground force, we document, and then we start brainstorming that, okay, fine, what are the data products that we need to build? What are the tier 1 data products that we need to build in order to, build the entire thing? So we do the requirement analysis, and then step 2, we get to digging. I call it data digging because when it comes to understanding what are the data product we need to build, we need to understand what's available. And from there, we need to also dig, okay, I have all this raw data, but what's the thing that I really need? Right? So we get to digging, we get to kind of understanding, is it an Excel file that I need to work with? Is it some kind of data lake that I need to go to? Okay, what kind of data are we working with, right? So we get to digging, that investigating and collecting what are the base tables required to build this tier 1 data product. Maybe one of the tier 1 data product could be a table where all the customer information is there. Okay, the customer name, customer region, their payment structure. Do they have some kind of code that if, they could be a customer that is very important to the company. It could be a customer that's not so important. Maybe a customer who's buying from the company on a day-to-day basis. So a lot of information, so we collect them. So this stage, we do a lot of digging. That, okay, what are the information and data we have? And then we get to step 3. This is where now we have some bit of understanding that what are the data that we need to work with. And then we start with building the tier 1 data product. So how do we build a tier 1 data product? It starts with data cleaning and data formatting. So imagine the cake, right? We're still building the foundation. So when it comes to building a foundation, it's very important that the foundation is very strong enough to hold the other tiers, right? So when we talk about building data products, it's very important that data quality is top-notch, right? So how do we make sure of that? We make sure of that by, cleaning the data, by making sure that the data is in the right format. We also make sure that we don't keep anything irrelevant in the data product. So what do I mean by irrelevant? For example, for this use case, maybe we got to have a base table with all the customer name, but maybe thousands of the customer don't even exist anymore. And it doesn't make any sense to keep these irrelevant customers in our data product. So we do a lot of cleaning and formatting in the first stage of creating the data product. And then we do a lot of feature engineering as well. So feature engineering is the stuff where, maybe when we did the requirement analysis, the user said, yeah, I would also like to give some kind of tagging to my customer. If it's very important, I want to give it a green tag. If the customer is not so important, I want to give it like a yellow tag. So this is where we do a feature engineering, right? That we develop certain logic on top of the data so that we can, tag these customers. So we do feature engineering, and then we get to testing. Okay, I have developed something, but is it good enough? So then we go back to our, end user, and then we go back to the customer, our internal customer, and say, okay, I have built this foundation. Do you think, does it look good? So we also do that, and we also do testing ourselves to make sure that, it's good to go for, the next step, which is basically step 4, where we do further documentation and industrialization. The thing that I hate the most is documentation, because I don't like documenting, but this is the most important part of any data product creation. We need to be able to feel comfortable in documenting what we are doing, because we cannot guarantee that we will be staying in one place forever, right? So it needs to be a system where everything is documented and everybody understands what's going on. So we do a lot of documentation, and then we get to industrialization, right? Then we make the entire thing come together, and then we create the tier 1 data product. So how do we then? So now again, coming back to the cake analogy, that we are done with tier 1, and I said tier 1 data products, they're basically base tables. So now we move to the tier 2, because whenever I want to give a product, I cannot just give my end user, okay, here you go, here are some base tables, work with it. I need to be able to give them a product. And to move to that direction, I need to create some kind of intermediate data product. So how do I create intermediate data product? A collection of a lot of tier 1 data product leads to the creation of tier 2 data product. And these are the tier 2 data product that can be used to build dashboards, that can be used to, for further analysis. And all of these all of these tier 1 data products are connected by something called business logic. And what do I mean by business logic? That how do business operate? How do a customer place an order, and then how does it pay on time? So all of these kind of, let us know that how should we connect the dots? How should we connect one tier 1 data product to another? So this is where, business logic comes into the scene. And it's very important that as a data analyst or a data engineer, that we not only know how to develop from technical point of view, but we also understand how a business operates. Because if we don't understand how a business operates, we will never be able to connect tier 1 data product to each other to then, develop something which is, usable. So we need to collect multiple tier 1 data product to then create tier 2 data product. And then, we go on, in a similar journey. We merge tier 1 data product, and then we also do some further feature engineering when we want to create the tier 2 data product. And further engineering means, like I explained in my previous slide, that if we want to build further logic on top of the cooked data, this is where we kind of do more further engineering, feature engineering, and then we again do testing, and again further documentation, right? Because the more work you do, the more documentation, and then get to industrialization process. So this is how we create tier 1 and tier 2 data product. And step 6, so now I have my data product, but now I want to build the final product, because again, I cannot just give my customer, okay, here you go, some advanced tables, go ahead, play with it. I need to give them a finished product, right? So what do we do? So first, once we have this tier 2 data product, we start a stage where we analyze this tier 2 data product and move to creation of dashboards. So we first do a lot of EDA, which is exploratory data analysis, where we try to understand, okay, what is the data pattern? What is the hidden meaning in the data? Is there some kind of trend we can see in the data? And this stage is very important for us to really understand, okay, what kind of dashboard and what kind of insights can we give to the business that will help them, make certain important decisions. So this is where, we do a lot of analysis part. And from step 6 is where the data analysts come into the scene. So from stage 1 to 5, you can say is the data engineer who are creating all this data product. And from step 6 is where the analysts come into the scene, where they analyze the data, generate a lot of insight from the data. So once we are done with this stage, we also do a lot of hypothesis testing, because my end user is saying, okay, the customer is late, but maybe is it really late, and to what extent? Or maybe this end users are saying, this customer is paying on time, but is it really true? So we do a lot of hypothesis testing as well to see, okay, what does the data really tell us? So then we also, analyze the data, analyze the patterns, derive insights, and then finally we move on to, interpretation and dashboard creation. We use a lot of different tools depending on, what kind of tool the company uses. It can be a Power BI, it can be Tableau, it can be SAP Analytics Cloud. So based on the tool the industry uses, we build, dashboards, nice looking, very nice, colorful dashboards for them to understand the data better and, see, okay, now my customer, okay, green customer, okay, paying on time. Yellow customer, okay, they're not paying on time. So they can see all of this, output on a really nice dashboard. So once we're done doing the dashboard generation, then we move on to something called, we initiate the development of AI product. Because now I'm telling my end user, okay, now you know how your customers are behaving, paying on time, not paying on time, but you also want to know, are they going to be paying on time in future? Are they going to be late in future, right? So in this step, 2 things happen. One, the data analysts, they're maintaining these data products, seeing the patterns, analyzing, okay, what's happening now. And then they're also, handing over these data products to someone like Shabab, the data scientist, right, for developing AI products. So now I will give you the floor, Shabab, to, talk more about that.
Yes, so I think just before I go to the section, so the bits that you guys saw here that Poheli presented, the first bit was more something that data engineers do, working with these tables. So, and then at the end was this dashboard part, which is typically what the data analysts would do. And then we move to the to the third part, which is where we are going to talk about the last level, AI products. And of course, it's the part I like because that's what I do. But to say, the interesting thing here is that it's some of the same stuff that Poheli already talked about. But when the data scientist then comes into the flow, they will again start the process by gathering requirements. And this is a bit interesting, but this is usually how things work in companies. And what happens is that we will again try to understand from this, almost like the start, you can say, but we will start talking to the business stakeholders again. And we will try to understand, okay, you want to see if people are going to pay on time or not in the future. What does that mean? Do you want to know if they will pay on time next week? Or do you want to know if they're going to do it next month? Or to what granularity do you actually want it? Do you also want to know it as a aggregated, so by department? Or do you want to know it for entire countries? Or do you want to know very specific to each thing? Do you want to know it by product or who knows what? So you again go into the details. And then you can also do some workshops and some shadowing where we sit next to the people who are already doing this today and try to understand how do they do it. Because most of the processes that people want you to do using AI, most often this is already being done in some manual way. So the best way to start is go and find out how do people do this today, and then you can translate that into some AI workflow. And after that, we go into this, you can say, very complex process in a way, but there are many different things. And what I'm really trying to say here is that developing AI products is an interplay between a lot of people, a lot of processes, and a lot of technologies. And it's similar to how the other process was as well, where we would start with defining the business problem first, and after that we will go with data acquisition. Note that the data engineers and analysts already did this to a great extent, but it could be that the type of predictions I want to do require data in a slightly different way. then I will again have to go back and talk to the data engineers and tell them, yes, the table has column A, B, C, but I also need D and E. Can you please make that for me? And that's where this interplay between scientists and engineers happen. And then once you have the data in sort of this right size and shape that you want, you go into the machine learning part, which is typically where data scientists spend most of their time. This is where you're trying to figure out things like, okay, what kind of technology should I use to solve this? What kind of model should I use? Is it more like a statistical model, linear logistic regression, or is it more deep learning model and XGBoost, or is it like neural networks, or is it a supervised problem? Is it an unsupervised problem? Or all of these kind of things you do in this machine learning bucket where you're trying to figure out how do I solve this business problem using techniques in mathematics and statistics. And that's typically where data scientists spend most time. And usually you can say a lot of people ask me, and you will see nowadays, since I was a data scientist, started being a data scientist 6 years ago to now, the number of data scientists has increased exponentially. Anyone who works with an Excel file is a data scientist these days. But that's at least according to LinkedIn what you can interpret. But the point here is, how do you then define a good data scientist from a not so good one? This will usually be in this machine learning bucket. A good data scientist is able to translate a business problem to a mathematical and statistical problem very quickly, very fast, very efficiently. Whereas a not so good data scientist will have this kind of a hammer and nail approach where they will have, let's say, XGBoost model, apply that to everything, and not really thinking about, is this what I really need to solve the problem? Which algorithm do I need, and why am I using that one and not something else to solve a particular problem? And that's where data scientists spend most time. But after that, we move into this yellow part of the slide where we are more in operations. And this is often the stuff that people in academia who are data scientists focusing on this machine learning bucket do not have so much exposure to and often miss out. So this whole aspect of ML ops, deploying models, it's one thing to develop a model. It's a completely different thing to deploy that model and make it in a way that thousands or millions of people can interact with this model seamlessly. And that is actually something very complex to do. And that's why you have this ML ops engineers who have that capability to deploy models at scale, basically. And at the same time, again, so I say there's one thing to deploy models, but it's also how do people interface with this model? So as a data scientist, you can make this very complex convolutional neural network with so many hidden layers and all this stuff, but the end user does not understand anything about that, neither in the business nor out in the real world. But the end user needs to interact with this model in some way. How do you do that? And this is where you are building some kind of an interface again, where the model is abstracted away from the user. ChatGPT is a good example of this, where everyone has one prompt box to put stuff down, but actually behind the scenes, they probably have 4 or 5 different model workflows, which are abstracted away from all of us end users. So we actually don't know this, but they are doing image generation, text generation, and numerical stuff all within that one prompt box that we see. But behind the scenes, they're doing so many other stuff, and it's going to many different complex workflows. So that's also very important in building an AI product, that how do you make an interface which can be used by users to interface with your complex AI workflows or AI algorithms. And then, of course, last but not least, you need some kind of feedback loop to gather the model that I have made. Is this still relevant today? Because as a data scientist, you will know there are terms called data drift and model drift. All of these models that data scientists make are based on some hypothesis, something happening in the real world. For example, if it rains, people stay inside. Let's say this is a hypothesis and you build a model on top of that. But what if, due to climate change and whatnot, it never stops raining and it always rains? Does it mean that people will always stay inside and never go outside? No. So if something in the real world changes, the model will also need to change. And this is where you, as a data scientist, always need to monitor, does my model still perform the way it was supposed to perform? And do the same hypotheses that I had when I built it still apply today? And that's some of the stuff in the operations area. So that's more or less how it works, and then I will just spend some time to put it all together and kind of explain that there's a lot of unseen complexity in all of what we do. At the top, you will see again that table or a version of that table, which, as I said at the start, it's supposed to take 2 days or something like this to do it. But as you have now heard, there's a lot of stuff that you need to do to get to just these 2 columns. And it's not straightforward. It's not just that you need to do a lot of stuff. It's also that you need a lot of people to do this. And it's a very complex process. And this is typically something that organizations don't understand, because they are just looking at these 2 columns and thinking, but why? Why is it so difficult? And that's, again, up to us, data analysts, data engineers, and data scientists, to go out there, educate senior management and senior stakeholders to explain to them, this is why it takes time. Because, it could be the data that you need to come with that table. Part of it is in an Excel file, part of it is in SAP, part of it is in a data lake. And you have to somehow combine all of them together to get to this. And then you also have to explain that some of that data is text, some of that data is numbers, some of that data is maybe even images, like pictures of invoices that people have delayed. How do you then combine all of this together? And these are the kind of things that organizational stakeholders, the senior management don't usually understand, but we have to educate them on that. But yes, so we have shown you tier 1 data products, base tables, clean tables, gather data, clean data. Tier 2, you combine your clean tables and get some aggregated tables, and then work on some dashboards to kind of show descriptive stuff and historical stuff. And then last but not least, tier 3, the AI products, where you are translating these tier 2 products into predictive and prescriptive stuff, and thereby helping people predict in advance what might go wrong. So that's kind of a 20-minute on data analyst, data scientist, data engineer, and what they do at an organization to realize use cases. We want to focus it on you. We are almost at the end of our slides, but I give it to Haley.
But now it's your turn. I want to ask you a question. So now you know how do we create AI product or data product, right? But there is an obvious, I would say, mismatch in this entire process. Maybe we could make this process more efficient. Can any of you, maybe suggest what could be made more efficient or, better in this entire approach that we take when it comes to creating a data product? Any brave person
in the audience?
Do you think something that we are doing is not really right? That,
or could be done better?
Could be done better, yeah.
You just need to raise your hand.
Yeah.
Oh, sorry.
I'm not sure. Should I do this? Okay. I'll take the mic. I thought actually that maybe one of the promises with AI isn't that we haven't to not to go through this complete process with design each time. That as an end user you can actually use it in a new way, find a new learning or through the AI after implementation. Where in your process it seemed like you need the full business idea each time.
Yes, that's the difference between good solutions and bad solutions. AI is not really there yet, where you can just say, here is this thing, do it all. It really is far, far, far away from that. You will need to define it in this way to be able to get the most value out of it. AI is actually pretty dumb compared to what most people might think. That's the hard reality. But it can do a lot of cool stuff if you're following this kind of process. But maybe
but maybe just to add to that, let's say the use case that we looked at, right? That whether my customer will be on time or, in future will she or will it be late? If I don't feed that information, the historical information to the model, it will not be able to predict, properly. It will just give you some random numbers, and then if you really trust it, you're gonna be like, okay, this customer will be late in the future. I'm gonna keep sending him some deadline email, but at the end, maybe it just predicted it wrong. So we need to make sure that we feed the model in such a way that it's grabbing the right data, and that's why it starts with developing a really good foundation of the data, right? So that the AI is learning on good data, not some really bad data, and then giving you wrong results, right? So, but Yeah, I mean,
maybe you have touched upon it. Oh, we have another volunteer. Yes.
Yes. So maybe I'm basing this too much on my own experience, but I think in this entire process, one of the aspects that's very much not talked about is the first push that starts it all and the validation of that idea. And is it worth the effort that it's going to take? I think that's pretty much the biggest problem with this entire workflow, because the complexity is explained why it's there, but the initial push is never validated. Does it actually gotta have
Should you actually
the
solve
impact?
this problem?
Yeah, exactly.
Yeah, and that's a very good point.
Yeah.
Yeah, not really where we were trying to guide you, but
That's a good point.
we
yes.
will answer that question in the Q&A. But for now, should I take it to the actual answer? But what we were trying to get more towards, and you will see it in the slide, but when the analyst came out and did stuff, they were doing all this requirement engineering and understanding what to do with the data, what to do with the dashboard. The scientist came into the picture and kind of did this whole thing again, but from an AI perspective instead, disregarding completely what the analyst and the engineer had done in the past. So why would they not do it together? And this is kind of a question that we are also discussing all the time ourselves. You can say that what comes first? Do you do, and this is higher level from an organization, do you do a data strategy first or do you do an AI strategy first? And it's almost close to like a paradox, because to do good AI, you need good data. Yep. But it also goes around. If you don't have good data, you will not know what kind of AI you can do on top of it. So it kind of goes both ways. So we leave you maybe with this paradox. I don't know if you want to add.
No, I mean, do we start with data strategy where we just think about, okay, how to make this data better, right? Well, how do we create a platform where users can grab the data and do their own analysis? Or do we start with AI strategy? No, my strategy is I want to be able to predict things. So we need to then build and move in that direction, right? So I think in the company right now, we are kind of like, at least where I work at, I think right now we are focusing more on the data strategy, right? Because we need to be able to make good data products in order to feed AI models so that they give, the results that make sense. But I think, Shabab, you would...
Yeah, I'm more the AI strategy side, right? But I also know the pros and cons with this, because you are also then tunnel visioned. Then you're only making the data required to do AI. But data is not used only to do AI. Yeah. You can do several other things with data as well. So then you're suddenly losing all of that. Yeah. But anyway, we can talk about this for hours. I see there's a hand, and we also hit the end of our presentation. Maybe we can start with the first question at the back.
Thank you. I think it was a very excellent question with the strategy, because it tells something about where do you want to start. Yeah. And the strategy, I think, doesn't matter whether it's called data or AI, because we put different things in it. It could be an IT strategy, is that the systems, data is the data management, and so on. So it's more about where's the vision for that company or your product. That's the strategy. How do you want to do it? And then you will have to figure out, what do I do with my data? What kind of technology or AI I'm going to put in? So I wouldn't put so much emphasis on whether it's called data or AI strategy, but that you have a strategy for your domain.
Yes. Do you want to...
No,
I can. I think you're generally right. First of all, the point you're trying to make is you need a strategy. Yeah. And that is absolutely true. You do need a strategy. Most companies out there don't have it. They just want to do AI. That's without any strategy, or they just want to do stuff with data. So yes, you need, first of all, a strategy. But I still think once you are getting there, there will be these chapters inside that strategy. And that's where we are kind of hitting, like, which chapter do you write first? Do you derive the data chapter from the AI chapter, or do you derive the AI chapter from the data chapter?
Basically the chicken and the egg, right?
Yeah. So, and this is complicated, at least. So,
right, because you can have a data strategy, you can have a methodology with AI, but you also need to know how they're going to adopt it.
Yeah,
so I think the personal part of the strategy is also
critical.
Exactly. I think adaptation, we were just talking about this before the session, that I think right now in the organization, no matter how fancy AI tools we build, there's also an aspect of adaptation, right? There are a lot of people who are not really comfortable with moving away from Excel files and Excel-based analysis to something really cool tool where I can, ask something and it will just give me some answer and then I just trust it, right? So the trust is not still there. We need to be able to educate this, I would say the organization that you can move away from Excel-based analysis to something more sophisticated, and it will basically save you time. It will not be something like cheating and using AI and making things easier for you, but it would be a way of working smarter, right? So the adaptation, right? It plays a big role. So I think there's also could be something like how before we think about AI, before we think about data, how do we do the change management, right? How do we adapt these new fancy ideas into the organization? Yeah.
Yes.
Very valid points.
Yeah.
What other questions do we have? Anyone else in the room with a question? Definitely.
Okay, nice to see the hybrid of both of you together, but this is also for some of the students listening. What does an ML engineer or an MLOps engineer do? And how different is the job from data scientist? I also understand in some companies you are the same person, but what if you had a lot of funding and you could hire a separate MLOps engineer and ML engineer? Yes. What do they do?
Yes. Should I take it? Yeah. So very good question, first of all. And I think it's a very valid question and something that we see in the industry more and more now. The way the industry has sort of evolved is everyone knew the concept data science first. So you hired data scientists. And they would work in this machine learning bucket, fine-tuning the models, making the best models, highest accuracies and all of that. But these people do not have the capability to put this into production. And this is typically what these ML ops or ML engineers are mostly working with. How do you take a model and put it in the cloud, for example? So most of the MLOps engineers would work with a lot of cloud technologies like AWS, Azure, GCP, and technologies like Docker, Kubernetes, and stuff like that, and figure out how can I make a model, convert it into something like an API, which people can then access and get predictions on the go. And this could be, you can say, in different formats. So for example, if you're talking about, there could be a model where millions of people are getting predictions. So let's say you go and you make a transaction with your card. This gets screened for if it is fraud or not by a machine learning model. This is one kind of model, and deploying that has a lot of complex technical requirements because there's billions of transactions happening every second. How do you make sure that this model can do all of that instantly? So that's one kind. The other kind, something I more work with, is you sometimes deploy models to a machine at an edge device. So it's not in the cloud, it's not in my laptop, it's not in a website. But if you want to do predictive maintenance, then this machine at a factory needs to have the model. How do you do that? Because these machines are not built in a way to have models. So these are the kind of things that MLOps engineers do. It's a bit bespoke, it's a bit different, and the industry is also getting more mature with it. Yeah, long answer, but we can connect on that. I would also like to answer his question, if that is possible, because I think it was a good question. So the question was, before we started Q&A, about validating if we should do the problem or not at all. And we kind of had the assumption that it is already agreed that you do it. That's why we went down this rabbit hole. But typically in organizations, you need to have this kind of prioritization bucket, you can say. You need to have some kind of boards where they are doing this initial assessment. In my own organization, we have something called a stage gate model. And over there, you have, in the first gate, you're just reviewing the idea, what business value it brings, and how much could it potentially cost. And based on that, you can shoot off ideas at first, right away, before diving into this whole thing.
Do we have one last question in the room? And I don't think we have any online. If people online still have questions, you can write it in the chat, and I'll forward them to Poheli and Shabab after the talk. Let's give them a big hand.
Thank you.
Excellent.